It's day 4 of Advent of Code, and we're solving the printing department problem today. So it's about rolls of paper that are arranged in some specific grid, and our goal is to find those rolls of paper that have fewer than 4 rolls of paper in the 8 adjacent positions. So specifically, for example, this one has only 3 adjacent rolls, but this one has 1, 2, 3, 4, 5, 6 ones. So it's about identifying those which have at most, or actually fewer than 4 rolls of paper adjacent to them, and those should be marked with an X, and then we calculate how many of those are there in that grid. So seems pretty simple. So I will just take this whole input, put it in here, and let's see what happens if we try to solve it. So we'll read the lines, and then we will do a map, which will be a map of it's going to be a two-dimensional array with height, which will be a number of lines, count, and then we will take the lines 0 as the width of the map. Or actually, better, let's do it like this. So it's X and Y, it's easier to think about it this way. So then we have, for this map, we will read in the map. So for X, for Y, and we will read in the map. So it's going to be just like this. It's going to be, okay, so width will be this, and height will be this. So it's easier to understand. So like this, and height. Well, and then what we will do is we will check which ones are movable. So movable will be 0, and for and Y equals 0, less than height, and for X, and then we do like this. And for each of them that we meet, well, we can do actually a separate method. That's fine. So we'll generate the method, and what we will do is we'll check if this specific location has at most 4 adjacent like rolls of paper next to it. So we'll do a private cons car roll will be this. And what we can actually do to make it even better is that we can make this, private car. We can do map here so that we have it localized and we don't have to pass it around. The same for private and width and private and height. So these will be variables that we can initialize. So initialize it like this, and we can then make it simpler a little bit. So now for this purpose, we can remove this whole thing, and then we can use those fields directly. So what we'll do is we will check if map, so actually for adjacent roles, we'll do 0, and we will do for each direction in directions, which is our useful, helpful with diagonals. So this is something that we created in previous years. It's like a set of directions in specific ways. So it's without diagonals, diagonals only, or with diagonals. So this is the 8 directions that we are checking. So we will check the direction. We take neighbor position will be our point plus the direction, and we'll check if it's within the map. So if neighbor position is less than or greater than 0, greater than, or equal, this is the check. So we'll check if it's not outside of the map, and if it's not, we will check if that position is a roll of paper, and then we add it to the adjacent rolls. And if we actually return adjacent rolls greater or less than 4. So this will check how many are movable, and then we just return the number of movable ones. Okay, so that should be okay. And now let's see what happens if we run this against our sample input. Oh, I used the wrong input here. I need to use the small one just to first check if we are doing the right thing. So let's see. Day 4. So it's 19. It's 13 actually. So there's something we are missing here. Fewer than 4 rolls of paper adjacent to it. Okay. So we're adding this, is checking if it's, well, all right, of course. That's an important check that I forgot. So this must be checking X and Y equals a roll. So because, we need to know that this specific location is actually a roll of paper, because otherwise we would be moving blank space. So this is 13 now, and we should be able to check now if the value that we get from our input matches what we are supposed to have. So let's take it here and run it with input file is this number, which is correct. So we have the first part solved, and let's go to the second one. So in this second part, we remove some rolls of paper, and that might enable us to move other rolls of paper. So we kind of iterate the same process multiple times. And the question is, how many total rolls are movable if we keep repeating the same process? So we move some of the rolls, and then we do it again and again. So the total number will be the result. So this seems to be a pretty straightforward extension of what we have now. So I will try to see if we can reuse the same thing and just adjust it a little bit. So what we can do is to do map. Well, actually, what we can do is to have to create a method that will return list of, or it can be a point array of move rolls, and this will kind of move all the rolls that are possible to move. So I will find movable. So it will find the movable rolls, and instead of counting them directly, it will do positions. It will be a list of positions that are movable, and for each of them that are movable, we'll just add it to the list and return the list afterwards. So this will give us the list of positions that are movable. And now we'll do this while true, and we will do movable position. Maybe it's exactly what compiler suggests here. So we'll find the movable ones. If it's 0, then we break because we no longer have anything to move again. And if we move them, we will just replace the position with a blank dot. And we should also count the number. So total will be 0 initially, and we will add up total plus equals movable positions length. So we'll add the number of movable positions, replace them with a dot afterwards, and then we do it again. So this will continue happening over and over until we are no longer able to move anything. And then we just return the total. So hopefully this will be good enough. The problem here could be that it will be running for a longer time for the big input, but it doesn't seem that huge, so hopefully it will be possible to handle this even with this like simple solution. So the test data is giving us 43, which seems to be okay. So let's see what happens with the actual input file. So I will find it here and run it, 8,946. And that is correct. Okay, so we have solved day 4 of Advent of Code. Thank you for joining me. I'm not sure if I will be able to do the next day tomorrow or the day after, but we will see. And I will definitely publish the video when it's available. So thank you and see you next time.